Hello, everyone, and thank you, Morgan, for the nice introduction. I hope you had a nice morning and a good lunch and are ready for an hour of conversation about architecture and how I came into place standing here today and sharing my career with you and what has happened so far. As Morgan has mentioned, I'm based between Los Angeles and Vienna. I'm the founder and director of JK Design GmbH, a company based in LA and Vienna. And I have been teaching here at UCLA since 2012. My work cross-disciplinary, looks into architecture, product, and fashion. And I'm interested in bringing digital fabrication, especially 3D printing, into the various different disciplines. I picked this picture today because I thought I share something which I haven't shown to anyone yet, ever. This is me in 2002, when I was 18 years old, and this was my first architecture project. This was at the University of Technology in Vienna. And I started studying with 500 students, 500 colleagues of mine. Is really big. And you really had to kind of stand out if you wanted to make a point and have your teachers actually pay attention to you. So what we learned in the beginning was drawing with pencil, but also I was really curious in working with my computer. They didn't teach us any computational design or CAD software at the beginning. And so I asked my friends if anyone was interested to organize a workshop in Form C. That's not a software which we use today any longer in architecture, but at that time it was the software which allowed you to do organic shapes. And so I taught myself Form C in the first semester and designed this beach pavilion. Here you can see a physical model what I built. This was the first architectural physical model I ever built. And a drawing which I actually drew by hand. So with a ruler and with a pencil. And so I thought to share this with you because it throws me back to that time when I was kind of your age and exploring architecture for the first time. Some of you are even younger than that. So it's exciting to meet you all. A little bit later, 5 years later, I was very interested in exploring and expanding my knowledge in 3D modeling. And I had the opportunity to apply for the University of Applied Arts. So I didn't finish my undergraduate at the University of Technology. I decided to transfer. And at that time, it was very competitive to get into the Angewandte in Vienna. They had Zaha Diet teaching there, Wolf Prix from Coop Himmelblau, and Greg Lynn, who is a professor who has been teaching there for 20 years. He just finished, and he has been teaching here at UCLA ever and for a really long time, and he's still teaching here. I was a student of him, and I got the opportunity to do an application process and was one of 4 students being accepted in 2005. So you can imagine going from a school where I was one of 500 to a school where I was one of 4 being accepted with 23 colleagues studying was very different. And so I think one thing what you experience in the summer program now, being one of 10 students, 10 to 12 students in a studio, is very privileged. You get a lot of one-on-one time with your instructor, and this allows you to get a lot of feedback on your project. So you should make utmost use of that and really talk a lot to your instructor, because this one-on-one time is where you learn a lot. At that time, the school had its first 3D printer, and I spent all my pocket money on 3D printing. I basically spent all day long in the 3D printing lab. All my friends asked me, why are you spending so much money on 3D printing architectural models? And isn't it more interesting to build models differently? And I was like, no, this is the future. I need to learn this. I need to know how to powder print. And so I spent all my time in the lab. And I'm going to share a video of that time. 2006, we did the Giant Robot Studio.
it might just be the world I'm living in, but it's like every single person I come into contact with these days is doing robotic buildings.
People itself move through the whole building, and the objects and functions also can move through the building, how you use them. So this is Mark Foster Gage. He is an architect working in New York, and he's also a professor at Yale University. And after that review where he looked at my model, I asked him if I can come to New York and work for him, and he said yes. And I was like, oh my God, this is amazing. This is an opportunity. I go to New York. I spent my summer there. I learned Maya. I saw it like as a really fruitful internship and just jumped on it. So it really shaped the progression of my career.
Especially I was interested in the design of the Tomo robot, which is a robot which shows a perfect rigid shell system, how the rigid shells are connected and that every shell is unique and how they fit together. My robot is really giant and it's like a big machine where everything is moving inside. So there are the big rigid shells which are more like stranded on the beach and stay and don't move, and the things which are animating the whole building are inside.
So I'm sharing this because this is really long time ago, and it was one of my, I would say, intermediate architecture project, being a student with Greg Lynn in the first semester. And we didn't have anyone, we had one workshop, one day in Maya, and I basically taught myself everything what you saw in this video. And this is a very different time today where you have technology seminars and you have instructors who teach you everything. But what I would still encourage you to do, go beyond that. Go beyond what your instructors show you. Sit down at home, research yourself on YouTube, like expand your knowledge beyond what the instructors tell you, because it just makes you grow so much more. And I know you're a different generation. I see it with my students today. It's a little bit different than it was at that time. But a lot of things you're going to learn from your colleagues and from teaching yourself. So use today the summer program and as an initiator, something which motivates you, but then go and do the rest of the summer, expand your knowledge on your own. You can do it. There's so much resources out there which will help you expand your knowledge. So this was my thesis at the University of Applied Arts, a biomechatronic research center in Manhattan. And I designed this roof to have like different kind of shading areas. This was my jury on my final review. You can see it was a very male-dominated jury. There's Patrick Schumacher in the middle. There's Klaus Bollinger. There is Eric Owen Moss, Wolf Pricks on the very forefront. There's Hernan Diaz Alonso. And I had to defend my project at that time in front of this jury. Luckily, everything went really well and was successful. But also I want to share this image because the time has changed a little bit, and also the kind of, we see a lot more women on the forefront in architecture, in architectural reviews as well. And so there has been a shift between 2009 when this picture was taken and today. And so at that time, I worked a lot with Rhino and Maya. Some of these software is going to be taught to you this summer, but also there was no Grasshopper yet. Grasshopper is a generative design technique, a tool which allows you to do generative design. And at that time, 2009, we were only kind of starting with that. And I was modeling things to look like parametrically. So everything here is kind of hand modeled. Today, there are tools which are much more efficient and allow you to be much more faster in the process. I was lucky and I got invited by Ross Lovegrove to go and work with him in London for 3 years. And some of the products which were coming out of this collaboration was, for example, the cosmic leaf for the Milan-based light company Artemide. At that time, Ross was really keen to bring the architectural design methods into product design. And as 3D printing on that scale was something which was realizable, we looked a lot into this technology. And so we moved from using 3D printing as a rapid prototyping technique to actually manufacturing elements. This was a light design, the column New Nature light, which consists out of 16 different pieces. Actually 16 of the same pieces. So there's one mold, as you can see, the bottom left piece is 16 times repeated, but you don't really see it in the overall column because of its complexity and how it's modeled. How did I got to Los Angeles? In 2010, I had the opportunity to come here with the Max Center Schindler Scholarship. If you're in LA and you have the opportunity to go and see the Max Center in West Hollywood, I recommend it. It's a really great place to visit. It has good exhibitions. And the Museum of Applied Arts in Vienna gives these scholarships for 6 months. So I came to Los Angeles and I documented the biodiversity here, from the oceans to the mountains to the Salton lakes. I documented all of these natural phenomena and got really curious in how are they actually built up and what's their underlying mathematical logic. And while I was interested in biomimicry and mimicking some of these designs or some of these aesthetics in my designs, I also wanted to know their mathematical logic. And so I decided to go back to London to the Architectural Association and do another master in emergent technologies and design, where we analyzed corals and their interesting porosity levels on the interior. We did CT scanning and 3D scanning of these natural artifacts and then tried to understand how their physical makeup is being designed. We developed codes and scripts and algorithms to mimic those porosities and gradients of these cellular structures. We also looked into robotic manufacturing of such elements for facade prototypes. This was for a conference in Canada. We also realized exhibition designs for the Architecture and Design Museum in Los Angeles. This was an exhibition design which was created with a material called Sintra, and it was all CNC machined. It's a plug and pull system and can be flat packed together to be shipped onto different continents. We showcased it as well in Amman at the Amman Design Week in 2017. Here in front, there's the Queen of Jordan and my partner Kais showcasing the piece at the opening. And so we showcased this exhibition at multiple different places in the world. At that time, when it was in LA, it showcased 28 of the best architecture student projects of California. In Vienna, the office is very small. I have only 3 people working with me. In Los Angeles, we are located in Playa del Rey, close to Playa Vista. It's also called Silicon Beach, where all the tech companies are. Our lab is solar powered. We have a solar roof, and all of our 3D printers there run with solar energy. We do a lot of research in 3D printing materials, prototyping. This was an ocean waste plastic material. We deposited it in a light. You can see some of the prototypes for our handbag designs and other products. And in LA, we focus more on research and kind of development of some of our products, while in Europe, we are focusing more on the production of things if we get orders in Europe. So I kind of divided this lecture into natural systems, starting with the mushroom. I'm inspired by natural systems like mushrooms, and they're kind of underside of these lamellas. And in many projects, this has come into realization. So for example, in this Humenium jacket, which I designed in 2015, on the right, you see a rendering, on the left, you see a jacket. I developed a Humenium pattern, which is generated parametrically in Grasshopper, and it looks like it's grown around the body. This was a project realized with Stratasys and 3D printed with a polyjet technology, which works similar to an inkjet printer, where it lays layer by layer material on a flatbed in color. This mushroom pattern and these lamellas also went into one of our first products, an entirely 3D printed handbag, where everything from the clasp to the pocket to the hinge is 3D printed. Why is that important? Well, if you think about anything what you're wearing or your backpack, for example, it consists out of multiple different materials. If it needs to be recycled or if it's trashed, you have to actually take all of these components apart and recycle them separately. So in the fashion industry and also in architecture, we're more and more looking into single material applications because they are more and better recyclable. And so this is something what we aimed in this product, that to make it all out of one single material, and therefore it's made out of a plant-based resin and can biodegrade under industrial applications. So it comes in different colors. We 3D printed all in-house. Even the packaging we make ourselves, and we make these pedestals to showcase them. Another such application of these mushrooms are actually these pedestals, where we 3D print them with a single shell. There's no additional material being used in the production process. It's very lightweight and optimized, and it has its structure integrated into the lamella. So it's basically like a thin shell of paper, but through its folding, it gets its rigidity and structural strength. This was showcased in Vienna at an exhibition where we showcased also some of our dresses. It's being used as a champagne cooler for fruits or for vases. And we have also developed it with 3D printing glass. In 2022, we showcased the crystal lamellas at an installation in Venice, in Italy, at the Italian Glass Weeks. So you can see here we used the mushrooms and its colors to inspire 40 different vessels. We also 3D printed the bases, and we developed a series of 40 different vessels. Why is this important? Have you ever seen a 3D printed glass object? Well, these are the first of its kind. There's only 3 companies in the world which can actually 3D print at the moment with glass. And this is developed with Swarovski, and that there is no such other, there's maybe 2 other designers who have been working with this technology. And so it's very innovative and new. And what is so exciting about it with the 3D printing? You can make 40 different vessels without creating any molds. That means you can just make any geometry and change it. And with the 3D printing technology, you don't have to create any molds, any additional material to create these. All you need is an extruder, which extrudes the hot glass, and it prints one of these vessels in 20 minutes. Initially, I was part of this research with Swarovski in 2018, where we 3D printed these spirals in glass, some of the first ever 3D printing glass in the world. This is when the technologists at the company all looked at it and were excited what the future might be for this. And I gave a lecture at the opening of the manufacture of Swarovski, and Markus Langes, Swarovski, he put this sentence on the wall: everything you want is on the other side of fear. I think you all want to succeed in the TNARC program, and you might be a bit afraid what's coming in the next 3 weeks. Well, be assured you all gonna be successful, and you're gonna be so excited on the final day to have completed it. And it can be a little bit challenging. Everything in life is challenging, but it will be rewarded. So I'm excited for you guys for this experience. Every challenge makes you grow. Every error, everything, when you fall, you stand up and you do it again, and it makes you grow. So one thing what I want to tell you is, if something fails and it doesn't go how you want it, you do it again, and then it's gonna work. It happened to me on many projects. The next subject from moving from mushroom is kelp. You can find this on the beaches here in California, and it inspired me to create the kelp jacket, also a 3D printed jacket with Stratasys. I wanted to have this photographed in a really great way, so I reached out to James Goldstein in the Hollywood Hills. He lives in a Lautner house, and I asked him, you know, James, I come all the time with my students to show them the house. can I come and do a photo shoot for my first 3D printed collection? And surprisingly, he said yes. And so we had a photo shoot for the Sporophyte collection at the James Goldstein House. And we also then developed some of these products for applications such as necklaces. We did a project with Google I/O on augmented reality. We developed different techniques for coloration, and we put the kelp pattern into a bag, which is also now one of our products. Moving from kelp to sponges. Sponges are extremely interesting because of their cellular makeup and their geometry and structure. And so I designed a dress which looks like it's molded onto the body. This dress was entirely created in Rhino, a software which you're going to learn in the next 3 weeks. And on the right, you see a rendering, and on the left, you see the dress. And it was 3D printed with an SLS technology, which is a selective laser sintering technique, also called powder printing. Moving from that to the Cite jacket, a jacket which was showcased at the Philadelphia Museum of Art, which was 3D printed in color on fabric. It's printed in multicolor, so there's no post-process of coloration. And initially we did some studies on our FDM printer where I put some fabric into the printer and tested this. It's printed without support material and then moves in a very interesting way. I was inspired by the Madagascan sunset butterfly moth and digitized the algorithm into a 3D file, which was later on 3D printed directly on white denim. And there's a video here. So why is this interesting? Why is 3D printing on fabric something to look at? Well, at that time in 2018, it was a technology which Stratasys just started to develop. And they came to me and asked me if I wanted to design a jacket for the exhibition at the museum. And I was very excited, but at the same time, I was also cautious because what I designed later on made it into their general product palette. And now they are going from designer to designer and they're showing how excited things you can do with it, which is great. If you're a pioneer, you show things and they get implemented into product lines. It's great, but then that means also let's move on to do something like another thing. Let's move on and do something even more innovative. And so I got the opportunity to do a 9 months research where I developed a dress which is doesn't have any sewing involved. So everything in this dress is buttoned together because I thought if I can print any geometry onto a fabric, why not also print the fasteners to put it together? And so this dress, the Arid dress, can be kind of in a cascading method, be worn with a trouser, with a jacket, with a blouse in many different ways. And in this 9 months research, we looked into adhesion, testing different fabrics, testing different geometries, and kind of checking what can be done with this technology in a different way. So you can see here different geometries inspired from sea urchins and from other sea creatures, and some kind of lichen systems and other natural patterns, and then being 3D printed onto the fabric. Because it's printed in these points onto the fabric, because it's a hard material, it moves into all of these directions. We also did some 3D scanning in this project and then developed a digital workflow which can map the 39 pieces which the dress is made of directly onto the body. which is not an easy thing because you have to use mesh relaxation technology to kind of simulate how the fabric performs. And you have to create a 3D model to visualize how the dress is going to look like. Then you have to unroll the surfaces, figure out how to 3D print it flat onto the fabric, and later on put it together and assemble it again in third dimension. This was showcased at the Vancouver Art Gallery recently. And another thing what was interesting about SALT, this subject, is the Columns to Crowns project, where we looked into 25 different column capitals inspired by the Nabatean architecture and developed these 3D printed columns for Amman Design Week in 2019, which also led to one of the larger scale 3D printed columns, which were exhibited at Bergman Station in Santa Monica for 2 years and were 3D printed in-house in our lab here in LA. In the next part of the lecture, I'm going to move to 3D printed fashion collaborations, starting with the hybrid holism dress in 2012. Maybe some of you have seen this in Paris or in New York. It's now part of the permanent collection of the Metropolitan Museum. It was first time shown in the Paris Haute Couture in 2012. We can make the sound a bit louder. Here you can see the digital design of this dress. It was created in Rhino and in Maya. At that time in 2012, there were no large file sharing platforms. Today we use WeTransfer, we use Dropbox, but at that time we didn't have that yet. The file was 2 gigabyte. It I mean, today this is still large, but it kind of pushed all the boundaries on my computer, on the engineering side, and I had to email each individual leaf to the engineer in Belgium and make sure and trust them they all put it together in the right way. And at the same time, there was no prototyping because this piece was so expensive to 3D print. We really only had one shot. So it was printed one piece. It was printed in 2 parts. You can see it on the right, put together with hinges. One piece took 7 days and it came out of the printer the day before the fashion show. And I had to find a model to fit into the dress because obviously it wasn't designed for a specific person. And with all these challenges, it was really exciting to see it on the catwalk. There's a picture of me being in Paris and seeing it in person. And the interesting thing, it made it then into architecture exhibitions, such as the Archilab in Orléans, but also into fashion exhibitions. This was Manus Ex Machina at the Met in 2016. That led to another collaboration with Iris van Herpen on the first ever 3D printed dress with flexible material. And at that time, the material had no name. You can see it. It was showcased at the show in 2013. Here you can see a digital design of the dress. It was created with Grasshopper, and you can see the seams on the inside. And here's a video of the process of how it was made. So it was 3D printed in 3 parts for one side, 6 parts in total, and then hand stitched together. It was 3D printed on the machine's EOS. So the machines would create this look like this. And we also did another collaboration with Iris van Herpen in 2014 for the biopiracy dress. This dress was made out of 13 pieces, which were hand stitched together and also extended on the bottom with some silicone applications. At that show, Iris collaborated with an artist where they shrink wrapped life models on the stage. And they showed 60 different looks, and one of them was this 3D printed dress, which later on was published in the National Geographic next to a 3D printed ear and a 3D printed NASA suit, because it was so cutting edge and novel. And this is Devin Windsor modeling at that time. You can see here the design is created in a polygon modeling technique, very complex, inspired by leaf structures. The dress is now part of the Phoenix Museum of Art, and in 2019, I gave a talk in Berlin. It was at a conference, and at the end of my speech, there was a woman in the audience, and she raised her hand, and it was a Q&A session, and she said, "Julia, I wish I would have known you, because I'm the curator of the Phoenix Museum of Art, and I had no idea how the dress we just acquired was ever made." And I was like, well, this is exciting. It was a collaboration with Iris. I didn't know the dress was acquired, so that's really interesting. And we started talking, and the Phoenix Museum of Art was really interested in showing a bit more about the process. And so we created these renderings and digitized them and created these beautiful prints, which were exhibited at the museum in 2019. This later on led to a collaboration with Chanel and Maison Les Anges in 2015. Sound up, please.
Fashion has to follow everything what's going on in the world. And I like the idea of the most iconic jacket of the 20th century, redone in a technique it was even not possible to imagine that one day such a thing could exist.
So Chanel and Maison Les Anges were really interested in bringing this technology into their traditional methods of creation. And we took the 1920s Chanel suit and digitized it and 3D printed it in several looks, and then embroidered over it with pearls and sequins and different kind of crystals to combine digital and traditional craftsmanship. There was also a following collection of handbags with a similar technique. And that led to a collaboration in 2017 with Ruth Carter. It was in summer 2017. I was in Europe. I came back and I had a voice message on my phone from a Hollywood costume department. And they were calling and they said, well, we are here at Bill Hargate's costume department and we are really interested in learning more about your 3D printing techniques. Would you like to come? And I said, yes, I would like to come. I had never done a film before. I didn't know anything about costume design or the movie industry. And I met with Brian Kugler and with Ruth Carter, and they kind of explained what they would like to do in the film. But they didn't mention to me that it was Marvel or Black Panther. There was a code name. It was called Motherland. And I Googled it and was like, Motherland is from the 70s, an old African film. Well, it's the first film. Nothing can go wrong. Even if no one is ever going to watch it, it's okay.
I have seen gods fly. I've seen men build weapons that I couldn't even imagine. I've seen aliens drop from the sky. Yeah. But I have never seen anything like this. How much more are you hiding? Hold up. Let's go.
We are home. My son, it is your time.
Show me my respect and bow down.
You get to decide what kind of king you are going to be.
So I started working on this design. We looked at traditional African patterns, Zulu patterns in specific, of married women. They wear these Zulu hats, and we started digitizing those patterns in the crown and in the shoulder mantle. And then we had back and forth meetings with Ruthie Carter, who would be like, I would like it more like this and like that. And then the illustrators would draw and redraw the designs. And so it was a 6 months process back and forth. We also did some prototyping, and then they created a black set and a white set. And once they casted Angela Bassett, I kind of started to look into it more, because obviously I knew who the actress now was. I knew that they would start the filming on the 6th of January, because that was my deadline when everything had to be finished. And I literally in January put into Google African movie technology, Angela Bassett, and it told me this is for Black Panther Marvel. And I looked at my partner Kais and was like, I mean, I don't know anything about Marvel, but I think it's like Spider-Man. And then they continued filming and so on. And then a year later, when it started to be sold out in pre-sale, I hadn't seen the film. I was like, oh my God, I really hope everything worked with this costume, because this is going to be a really big film. And so we were all really nervous, but I saw it like everyone else on the first day when it premiered in the movies. And I went with Ruth to see the film. And I have to tell you, it was the most exciting moment, because I just saw what kind of impact it had on the whole Afrofuturism movement, and how it impacted at that time the change of like the Queen and the story and the influence it had. And so that made me really excited, because all in a sudden I had my friends who never really knew what I was doing, because I was doing things for Chanel, which were very exclusive. No one could really go and see. All in a sudden, this was in the homes of everyone. Everyone could go and see a film in the movie theaters. And so it made the technology and the application and the design process much more understood and also acknowledged in a way. And then you can see here a couple of visualizations of how it was printed in several different parts. And it led to Ruth Carter being the first African-American woman winning an Oscar in this category. And she asked me to design a 3D printed stola for the award ceremony. And you see here, this was in the technology lab of Shuri, and you might recognize that light in the background. So when I was sitting in the film, it's like, hang on a moment. There's a dozen of these lights in the technology lab. How did they make it in here? I designed those 11 years ago. So that was another surprise. I didn't know about. The production design team had sourced those and put them in the film. So that was really great. And that led to a second collaboration with Ruth Carter for the second film.
No woman, no cry. Little darling, don't shed no tear. No woman, no cry. Good friends we have, and good friends we've lost along the way. In this great future, you can't forget your past. So dry your tears, I say.
So for this collaboration, we obviously had to do it differently than in the first collaboration. We had to make it stronger. The character had advanced to being a more powerful role in the film and in the story. And therefore, the regal attire had to kind of reflect that advancement of technology in its design and in its aesthetic appearance. And you can see here some of the digital renderings of the crown and how it was developed. And it was produced in various different colors for different scenes. There were also a lot of stunt scenes in this film. And here's a video of the creation of the pieces. So you can see it's like in its natural form white, and then they use different techniques to color it and to kind of work over it for the film. And that led to Ruth Carter winning a second Oscar in the category of costume design, and makes her the first African-American woman winning 2 Oscars in this category. And she asked me to design her earrings for the Oscar ceremony. And that was really exciting time to, again, be part of this team. And the costume design team is usually 60 to 100 people. So it was very exciting to kind of be part of this. And if you're from London, or if you ever go to London this summer, there is a really exciting exhibition for teenagers in the Science Museum, where you can actually, for the next 10 years, see the shoulder mantle. You can touch it in person. They have recreated the Shuri Technology Lab there. And so that might be an opportunity for seeing it in reality. Now, moving from collaboration and co-production to my work here at UCLA, and how does all of this work apply into architecture? I teach here in the master's program technology seminars. I teach introductory design courses, and this is some of the work what we have created in something called Introduction to Computers. This course now advanced to being called Mediation. And because Introduction to Computers seemed a little bit outdated in today's time. And in this course, you will basically get an introduction to all sorts of software. And this is some outcomes from the building construction classes I teach, where we take students on site. We look into construction methods and innovative material aspects and resources. Usually this is tied to a comprehensive studio in the second year. And at the beginning, when I came to UCLA, I used to teach with Greg Lynn for 4 years in the post-professional degree in our robotics lab offsite. We have an offsite campus in Culver City. And we used to collaborate with Boeing and Cirque du Soleil, some industry partners, where we experimented with innovative applications of these robotics. This, for example, was an infusion mold system for composite fibers. We did a lot of 3D scanning with the robots, injection molding techniques. Some of the technology seminars led then also to papers which I published, for example, with robotic fabrication, architecture and design. And this was robotic timber assembly, which was based on the jittery joint system, and was a system which is without any glue or fasteners, a system which allows you to reconfigure a timber assembly proposal, which was also published in Construction Robotics Journal. We did also some clay 3D printing with robotics and looking into innovative technologies. And this kind of accumulated in a research studio, which I taught for the first time last 2 years ago, where we looked into 3D printed facade systems. So everything what you kind of saw today in the lecture is something where I was interested to bring this back into the architectural realm. One might think, why did she do not architecture from the beginning? Why did she first do products and fashion designs? Well, for one, I was really interested in product and fashion, but for the other, some of these technologies only existed 10 years ago on the small scale. There is yet no technology which can print some of these things, what you're seeing, on an architectural scale. So I used fashion and product as a model scale to explore digital and computational design techniques on a smaller scale, and only now slowly find the opportunity to collaborate with larger scale 3D printing companies to apply it on a larger scale. So you can see here the students' work looking into multicolor filaments inspired from feathers. This is a project from Shushi, where he looked into multi-material filaments and printing supportless on an FDM printer, and then designing a facade for a building in downtown, which is a retrofit facade for a 100-year-old building, which is supposed to provide more shading and help with the advancements of hot temperatures in this climate change. This was a project from Yusu Wang, where she looked into butterfly systems and a facade which is 3D printed on fabric on that scale. On a larger scale, it would be 3D printed elements mounted on a net or a scaffolding, which is then applied in front of the building and can control the sunlight and the shading situation. She 3D printed the entire facade with a resin technology and then hand painted the model. A project from Daniel Rodriguez, he showcased an interest in this fern, and he looked also into AI image generation and created these tubular systems which are working as a structural retrofit for the building. He looked into not only creating a facade, but also retrofitting the internal structure of the building, and looked into Baroque plans and systems to create a jacket for a building. So the task for the studio was really to build up on Gottfried Semper's principles of dressing for buildings from the 1920s, and looked into how can we create jackets for buildings. So each of the students chose a natural system and then developed first a fashion application and later on a design for a building. And the last project I'm sharing with you is the Cactus homes, which is a design concept which we developed for an international competition.
Our design draws inspiration from the remarkable intelligence found in succulents and convergence with cutting-edge 3D printing technology. Through a generative design process, 9 unique cactus-shaped forms inspired by Texas native cactus are strategically positioned within the boundaries of Vulcan's print bed. 6 structures create homes, while the remaining 3 act as rainwater storage tanks. Our motivation in this initiative is to leverage 3D printing and showcase that good design can be affordable and benefit our underserved communities. The natural forms showcase mass customization to promote individuality while embedding sustainable and functional design features. The Cactus homes exemplify the potential for affordable, resilient, individually unique, sustainable, and community-based housing inspired by nature and made possible through advanced digital design and digital fabrication.
So we created this for an international competition called Initiative 99, organized by I Can Build in Texas. They are one of the few really well-funded startups in 3D printing concrete technology. They work mostly in affordable housing, but also they collaborate with NASA and the defense industry. And we were part of 300 offices and students submitting. They had two categories, student category and professional category. And they had participants from 60 different countries, and we made it into the final round of 8 selected projects. We got an honorable mention, and we are now in the second phase of developing this design further. There was also one of the students who is now a graduate, an instructor in this program, Kinami. He was part of this first phase design process, and is also part of the second phase now, together with another graduate student, our alumni, Thomas. So what we designed here is affordable housing, 6 units in 1 3D print bed of the Vulcan 3D print bed. We had additionally also a team in Vienna working with me on this, with our Vienna office, Oliver Hammedinger, Naomi Naurura, and my friend Steffi Thaler and Lucy. They are all part of this team. And we developed a system which can be printed and built under $99,000. So the idea is also that you have a sustainability kind of concept where we collect the rainwater, we use solar roofs, we use natural ventilation, we did solar analysis and kind of optimized for the size of their current Vulcan 3D print bed size to create these communities. And the idea is to not only kind of bring the natural phenomenon of the cactus shapes into the kind of living room spaces, but to combine it with traditional kind of roofing and use these advanced generative design methods also in the water tanks and the planters surrounding the landscaping around. This concludes my lecture. I'm really excited to share the work with you, and please follow us, and I'm here for questions if you have any.